What's up, guys? Restaurant Po'boy coming at you. Today we're going to go into why I very adamantly believe we can get together and start making Tesla Superchargers and Turbochargers in ways that will outdo all other Turbochargers out there now. Okay. So yeah. Here are the improvements and technical things to sort out in order to make it possible. Number one, remember 99% of all all Tesla turbines and pumps out there on the internet are copycats of the original 1909 turbine and 1909 and 1913 fluid propulsion centrifugal pump designs, which were missing a shit ton of improvements, including the spacing, the dynamic, the calculations on the gaps, getting ironed out exactly between each disc to do whatever you want to do with fluid, and especially the spoked washers for even and balanced spacing between the discs, which were in the British patent 24001 and the USA patent 1,061,206. 2. You need a good super alloy, like the super alloys we use in gas turbines now, or nitronic stainless steel for stability, strength, longevity, and rigidity. Now, for points 3 and 4 that I'm going to go into, I got a separate clip for that. Let's jump to it. Hey guys, what's Shrimp Po'boy? This is the clip going into points 3 and 4 of the fluid propulsion centrifugal pump, as Tesla, described and advanced. So, the fluid propulsion centrifugal pump, as Tesla himself called it, needs to be engineered at the bare minimum as close to what Tesla explained across all of his patents and failed patent applications on the pump and motor. That includes making the centrifugal orifices shaped like tilted, curved teardrops that are symmetrically able to line up in a precise circle, okay? As shown in the original patents for the fluid propulsion pump and the Tesla turbine patents. And this failed patent application to try to expand on the concept that was turned down by patent officers, and then the appeal he sent to the Board of Appeals at the end of May 1914, it was rejected again. See these curved, tilted teardrop orifices? See how they're symmetrically aligned? Good. That is needed for the centrifugal pump to properly work. If you notice, the fluid propulsion pump pulling a vacuum on the exhaust of this fat rotor set, this Tesla turbine, to get a final work extraction out of it, out of what fluid he's gonna. Jeremiah Forwarda and his colleague, may rest in peace, died. The help that was from the UK that partnered with him. It was when this all started. It was called Energy Supply. It's just Jeremiah Forwarda now, but still. You see the rims of these turbine discs are very flat when they should be round and smooth. Now you see my issue here, point 4. These are not on the pump pulling the vacuum. These are not curved, tilted, teardrop-shaped orifices. They are the same type of orifices on the turbine. You don't want that. You want what I'm telling you, what's in the original documents, what's in the original works. Now, point 4, you need the edges or boundaries of the tilted, curved, teardrop-shaped middle orifices for each fluid propulsion centrifugal pump disc to make the rotor, for each disc to be rounded and smoothed. just like you want the rims of the turbine discs as shown here. These orifices need to be rounded and smoothed in their boundaries. To facilitate the Coanda effect and ensure the boundary layer effect are both at their highest so the disc can grab on the air and compress it. The fluid propulsion centrifugal pump, as Tesla himself called it, needs to be engineered like this to get the best effect. And that, I will continue on with the next clip. Thank you for watching. Alright, let's get back to the rest of the video. Hope you enjoy the emphasis on what I was trying to tell you. You want the tilted curved teardrop orifices at the center of the fluid propulsion centrifugal pump, and you want the boundaries or the edges of those orifices to be rounded and smooth like this. Just like you would want the rim of each turbine disc to be rounded and smooth, to ensure the Coanda effect and boundary layer effects and the grabbing of fluid, in this case air, to compress it are possible and maximized. You have to do it this way. It is a must. Period. Now you know why I'm so adamant in emphasizing the importance of this, because without the Coanda effect, the boundary layer effect is going to be harmed, and you're not going to get the best effect of all. You need them together. You need them. Because the discs won't be able to grab without the Coanda effect. So anyway, go ahead. Let's go ahead, shall we? I'm going to glance at this and look back at you and keep on track. So, number 5, a Tesla pump builder needs an absolute symmetrical design baseline and factor in as much as possible for helping to align the center of balance with the center of symmetry and dynamic balance and techniques, which are largely already solved. And can be done. There's modern calculations that could go for this now. You got CAD file drawings that can help finalize these things. And then we have the means to fabricate using, 3D milling, sintering, water jet nozzle cutting, and all sorts of stuff now. 6, you need to use, at the worst, roller bearings that are made in such a way that you have nitronic steel to diamond black ceramic contact. Remember that. Metal contacting ceramic only. Not metal to metal, not ceramic to ceramic. Metal to ceramic contact only. Nitronic is the strongest type of stainless steel, if you didn't know. Why roller bearings and not ball bearings? Well, for a ball, you got a little pinpoint contact of friction, and that is your failure point. Whereas the roller bearings, it's all across the surface of the roller. Need I say more? Alright. 7. You need tight gasket seals on the pump system. This is being worked on as we speak. I would not be surprised if gaskets and seals for turbochargers already existing could be more readily modified and applied to the system. 8, without using the spoked washers between each disc and strong materials in the building of this centrifugal compressor design, without doing these things, it will eventually start to distort, and you will not get the same performance out of it you want across all engine RPMs to ensure it sucks in, pressurizes, and blows out air. Pressurizes, I meant to say, sorry. And it can eventually destroy itself from the warping and distortion. 9. Tesla pumps for air can already be at 98+% efficient. But only if you follow what I've already listed throughout this video. Follow all the things Tesla explained in his patent applications. that failed to go through, and his successful patents on both the turbine and the pump as your bare minimum baseline, and then factor in the modern modeling methods and cutting and milling and all the fabricating tool means necessary that you can use nowadays, that I would consider necessary for the best results for modeling these machines in order to do the designing of this properly. Like I've said in episode 1 of the Tesla Turbine Advancement Trilogy. 10. Once these prior issues have been figured out and things are out of the way, the next step is to make the centrifugal pumps and compressors able to be driven by belt, be driven by chain, and lastly driven by exhaust. Just a regular exhaust turbine like on regular turbochargers now. If I dare say, I think sequential turbocharging will be even more effective, much easier, more affordable, and much more rigid, which means turbo and engine longevity will be higher. Regardless of whether you got a small conventional turbo or a small Tesla turbo for low engine speeds, and then they feed into a bigger, larger Tesla turbocharger, whichever of the two you chose, along with intake air at higher engine speeds. The implications for fuel economy, power, rigidity, longevity are huge, okay? But due to the massive air density, pumping and compressing a crazy amount of air volume in a little bitty space, even better than the Latham axial flow superchargers that were modernized and originally sold through axialflow.com. And the man, I contacted him. He doesn't do it anymore. He doesn't make these anymore. But he modernized the Latham axial flow supercharger with modern machining, modern part fabrications, more aerodynamic blade designs in the compressor, and he made it able to work across engine RPMs. Small sacrifice in efficiency, but it still works way better than any other supercharger design. He stopped selling and making these and selling them, though, a long time ago. And I don't know that because the man who owns the business, I contacted him by phone and talked to him about this. That's what he told me. So he still sells these, like what they call the axial flow brand stick shifters. This fluid propulsion centrifugal supercharger or turbocharger could make two-stroke diesels bigger powerhouses than they have been. Even if we use one of these just to feed an old roots blower system. Although you could use the supercharger of this design to replace the roots blower and give plenty more air than you needed for conventional scavenging of a two-stroke system. I mean, this and make it a double chain drive. It would simplify the construction of these engines. And with modern engine designs, if we used, the flathead engine design for two-stroke diesels, which is unfortunately, I'm gonna have to retract what I said in my video on reverse uniflow two-stroke being better for diesels. Theoretically, it's true, but in practice, it's not so far. I'm sad to say I was wrong. But I'll keep the video up to show I was wrong, and I'm owning my error. I'm owning my being wrong. Openly. So yeah, there is no reason. Think of a big ass amount of air volume, little bitty turbo. Hell, you could technically, it'd probably be easier to use the smallest conventional turbo to feed into this sucker at mid to high RPMs and then have the regular small turbo work for the low RPM. That's probably your best bet, but still, it's a bit more simplistic, because trying to calculate how small you'd have to go, it would be a mess. So I was wrong on that other part. But overall, things could actually be easier outside that little nick in my detail. That one detail, it's a bit of a nick there because of the abilities of it. So anyway, thank you for listening, and I hope you see why I am all for Tesla fluid propulsion, centrifugal, superchargers, and turbos. Take care of yourselves.